Welcome to the Tune-Up module, the third in our series on air toxic standards for area source boilers. Reducing the amount of fuel used by boilers is one of the most cost-effective ways to control hazardous air pollution. A boiler tune-up optimizes the air-to-fuel mixture for the boiler's operating range. This in turn ensures that less fuel is wasted. It also reduces emissions of hazardous air pollutants produced by inefficient combustion. Periodic tune-ups not only improve efficiency and reduce air pollution, they also save you money. Before we demonstrate a walkthrough tune-up, let's review the required tune-up schedule. If you are subject to this requirement, you must have your boiler tuned every 2 or 5 years, depending on type and use. Keep in mind there are no initial tune-up requirements for new boilers of any type. If your boiler falls under the 2-year schedule, the first tune-up must occur no later than 25 months after initial startup. Those on a 5-year schedule must conduct their first tune-up no later than 61 months after initial startup. Subsequent tune-ups continue on the 2 or 5-year schedule as applicable. The category of boilers required to have a tune-up every 2 years include coal-fired boilers with a heat input capacity of less than 10 million BTUs per hour that do not meet the definition of limited use boiler or do not use an oxygen trim system that maintains an optimum air-to-fuel ratio. Oil-fired boilers having a heat input capacity greater than 5 million BTUs per hour that do not meet the definition of seasonal boiler or limited use boiler or do not use an oxygen trim system that maintains an optimum air-to-fuel ratio. Biomass-fired boilers that do not meet the definition of seasonal boiler or limited use boiler or use an oxygen trim system that maintains an optimum air-to-fuel ratio. Boilers required to have a tune-up every 5 years include seasonal boilers, limited use boilers, oil-fired boilers with a heat input capacity equal to or less than 5 million BTUs per hour, boilers with an oxygen trim system that maintains an optimum air-to-fuel ratio that would otherwise be subject to a 2-year tune-up. If your boiler burns more than one fuel type, the tune-up must be conducted while burning the type of fuel that provided the majority of the boiler's heat input for the 12 months prior to the tune-up. For example, in our upcoming demonstration, we are tuning a dual fuel-fired boiler that primarily burns gas with oil as a backup. Because oil is burned more than 48 hours during the year, this boiler is subject to the rule. However, since gas is the primary fuel, the tune-up must be conducted while burning gas. We will now walk you through a boiler tune-up. However, this is an example only and not all-inclusive. Depending on boiler type and design, tune-up specifics may vary. Refer to your manufacturer's specifications and EPA's website for the Technician's Tune-Up Guide for more technical details. This tune-up is conducted by a professional service technician from CNC Boiler in North Carolina. Joe Hodges will show you what he looks for and how he conducts a typical tune-up.
Today's topic is combustion tuning. I'd like to first start off by saying that only qualified personnel attempt to make any type of adjustments because improper adjustments can lead to equipment damage, personal injury, or death. We want to discuss required tools for combustion tuning. I'd like to first start off by saying that the boiler needs to be at a normal operating temperature or pressure before any adjustments are made. The number one tool that a service technician would need to perform a combustion tuning would be the portable combustion analyzer. This portable analyzer should read at least 4 things minimum. It should be able to read O2, which is oxygen. It should be able to read CO, which is carbon monoxide. It should be able to read NOx, which is nitrogen oxide. It should also be able to read stack temperature. With those minimum 4 things, then the portable combustion analyzer can take a flue gas sample and to determine overall boiler efficiency and combustion efficiency. As you can see, the boiler that's running behind us, we're taking a sample. The O2 is 6.4%. We have minimum CO at 2 parts per million. Our NOx is 95.9 ppm, and our stack temperature is 374. With a good portable combustion analyzer, the technician can print out a report, and then all of these parameters can be transferred to a test fire sheet. We would take readings at 0, 10%, 20, 30, 40, 50, all the way to 100% firing rate. We would record all of these readings: our O2, our CO, our NOx, stack temperature, gas pressure, furnace pressure. All of these would be recorded and used later on at the end of the process. A good boiler service technician would do a visual inspection before any combustion tuning would be done. The visual inspection would be conducted. He would be looking for adequate ventilation. That adequate ventilation would consist of stationary air dampers. It would also consist of combustion air dampers or forced air fans. I'd like you to remember that the forced air fans and combustion air dampers would have to be interlocked to the boiler, which would allow the boiler to start only after those dampers are proven open or those fans were running, because adequate ventilation will greatly affect the boiler's overall combustion process. The size of the ventilation for the room needed is just a rule of thumb: 1 square inch per 2,000 BTUs of input. If you're using ducting, then that would be 1 square inch per 4,000 BTUs of input. The next thing on our list, our visual inspection, would be to walk around behind the boiler, and we would take a visual inspection of the flame. We would look for clinkers, soot, and unburnt fuel that may have accumulated in the furnace. This is a note to the service technician that some adjustments are required, because we do not want fuel impingement or carbon buildup within the furnace, because this would actually increase emissions. Also, a visual inspection of the burner should be made before any adjustments are made. The burner has a single point jack shaft system. We would also inspect and make sure that all linkages are tight and no loose or broken components are noted. Our combustion air damper is pretty stationary. We would also ensure that the fuel curve or fuel cam, the screws, pins, and springs are in their normal position. We'd also would inspect the fuel linkage, which drives the combustion fuel valve. We would make sure that it was in a proper position. The boiler service technician would first have to take firing rate into manual and lower the firing rate to the 0 position. Once the burner is in the 0 position, we can start taking an actual reading. We would want to let the unit settle out for a little bit, or the flue gases to flow through the boiler to where we would get an accurate O2 reading. The adjustments would be made on the first pin, and at that point we will adjust either air or fuel to lower the O2 to the manufacturer's recommendations. We want to have as little CO or no CO as possible, because carbon monoxide is an indication of unburnt fuel, whether in a lean condition or a rich condition. As we make this adjustment, we will record that first position, the O2 reading, CO, NOx, stack temperature, in the first column for the first screw. We will then take the boiler back into manual and raise it up to the next point, which is 10%. And in 10% increments, we will increase our firing rate from 0, 10, 20, 30, 40, 50, all the way to 100%. And we will take all of those readings and transfer them to our test fire data sheet. Once completed and we're at 100% firing rate and we're done with our combustion, when we would then put the boiler back in automatic. Once all the readings for oxygen, CO are taken and your final test fire data sheet has been completed, this information can be transferred to the Form 6J for the EPA. In conclusion, after the boiler service technician has taken his final combustion readings and recorded those, the boiler manufacturer requires us to check all safety components. Those safety components are listed as the first low water cutoff, the auxiliary low water cutoff, the low gas pressure switch, the high gas pressure switch, the combustion air pressure switch, and the low oil pressure switch. Once all of those safety devices are found to be in good working order, then the technician is done with his combustion setup and tuning. Even though the EPA does not require semi-annual tune-ups, the boiler manufacturer will strongly recommend that boiler tune-ups be done semi-annually or twice every year, in the spring and in the fall. As air temperature changes, so does air density. That density greatly affects overall combustion. Our boiler manufacturer recommends this boiler be tuned twice a year. This will help save in fuel costs and lower emissions throughout the year.
We hope this walkthrough tune-up has been helpful. If you need more information on specifics of a boiler tune-up, EPA's website provides both a technical and small business compliance guide to help. Be sure to refer to the other modules in this series for further compliance information and reporting dates. As a reminder, initial tune-ups for existing sources are due no later than March 21st, 2014. New sources are not required to perform an initial tune-up. Thank you for your time.